This is week 5 for our simple machines, and this week we will be dealing with the wedge. But before we move on to the wedge, I want to look at the inclined plane and review some of the homework and discussion questions. Here's the homework for inclined plane. If we read the first question here, it says, Shannon lifts a crate into the back of her truck. She exerts a force of 200 newtons, a distance of 1.2 straight up. Calculate the amount of work done on the crate. So here is the formula that we will be using. Work equals force times distance. We know that the force that she put in was 200 newtons. We also know that the distance was 1.2 meters straight up. So if we multiply those together, 200 times 1.2, we get 240. 240 is the amount of work that Shannon has done. Now, if we look at number 2, it says, then she used an inclined plane to move the same crate into the truck. She exerts a force of 77.5 newtons, a distance of 3.1 meters. Okay, now with the inclined plane, the force she had to put in was less, at 77.5. However, the distance that she had to put in was greater, 3.1. So, the first question says, what is the work done? Again, we will be using the formula in the red box. Sorry about that, we didn't fill in the 240 in number 1 there. So again, on number 2, to figure out what is the work done, we will be using the red box again. And we have the force of 77.5, and we have the distance of 3.1. When we multiply those together, we get the amount of work done is 240.25. We notice here that the work has actually increased. What is the lineal measurement, MA? Okay, so here we're talking about length, right? Lineal measurement, we're talking about measurements, so we need to look at this formula here. Mechanical advantage equals slope length divided by height. So, in number 2, we know that the slope length, okay, or the inclined plane here, was 3.1 meters. And we need to figure out what the height is. But we know what the height is because in number 1, it told us that she lifted the box 1.2 meters straight up. So, we will be using the blue box, and we will be dividing 3.1, the length of her inclined plane that she's going into the truck there with. And the height we know was 1.2 meters straight up. So 3.1 divided by 1.2 equals 2.58. So the mechanical advantage is 2.58. Now, the third part here in number 2 says, what is the mechanical advantage calculated from the forces? Okay, and we know that this time we will be using this orange box, force out divided by force in. So let's see if we get the same mechanical advantage with the lineal measurements and with the forces. We know that the force out was the R, the weight is 200 newtons. And that was told to us in question number 1. We also know that force in, the force she put in this time, was 77.5. So the box originally weighed 200 newtons. That's what she had to lift straight up into the car first time. The second time, when she got the inclined plane to do this, to move the same crate, she only exerted 77.5. That's the force she put in. So 200 divided by 77.5 equals 2.58. So our mechanical advantages for both of those show up to be the same. The interesting thing about number 1 and number 2 is that when she used an inclined plane, she was able to decrease the effort, okay, because she had mechanical advantage. However, the work she did actually increased because of the distance that she had to push it up the ramp. Let's look at number 3. This time, Shannon used an inclined plane 5.2 meters long. So this time, she got a really long ramp. It's 5.2 meters long. What is the lineal measurement MA? So we're going to do slope length divided by the height. And again, we know the height is still the same. We didn't change trucks. So it's 1.2 meters straight up to get it into the back of the truck. So the slope length is 5.2. The slope height, the height there, is 1.2. We know that from number 1. 5.2 divided by 1.2 equals 4.33. So the lineal measurement of MA is 4.33. Now it says, what is the effort force she exerted? And if you notice the little asterisks there, it says, and there's little asterisks at the bottom of that question, it says, look back at previous homeworks for this formula. So we are trying to figure out the effort force, okay? The F, okay? We're trying to figure out what force she exerted, what force she put in. So when we look back at our notes, we can find F equals R over MA. We have the R, right? The R is the weight of the box. Mechanical advantage, we just figured out with the blue box. So we can figure out the F. $200 is the R. We know that from question number 1. Mechanical advantage is 4.33 because we just figured that out with a lineal measurement. Now we can figure out 200 divided by 4.33 equals 46.19 newtons of force is what she put into moving the box. So that was the effort that she put in, 46.19. What is the work done? So here we're going to need to use our work formula. Work equals force times distance. The force she put in, well, we just figured that out, 46.19. The distance tells us in the question, Shannon used an inclined plane 5.2 meters long. So 46.19 times 5.2 equals 240.18. Once again, there is more work done than when she lifted it straight up. More work done, but less effort. Okay, that's why we had those 2 words in our notes this week. Let's look at number 4. The next day, Shannon grabbed a short inclined plane to move the same crate into the back of the truck, The ramp was only 2.1 meters. What is the lineal measurement MA? Okay, so we're going to use our blue box here again. Slope length was 2.1. The height, same truck all the time. Bumper hasn't changed. We're not having, the back of the truck is at the same height. Hasn't changed all day here. So 2.1 divided by 1.2 equals 1.75. So the lineal measurement MA is 1.75. The next question says, what is the effort force she exerted? So once again, we need to use our green formula here from a previous homework. We're looking at the effort force she exerted, the F, force in. We know that the R is 200, and we know what the MA is because we just figured that out. So 200 divided by 1.75 equals 114.29. So the effort she put in was 114.29 newtons. Okay? And finally, what is the work done? Once again, work equals force times distance. We will use the red formula. 114.29 is the work she put is the force she put in. We just figured that out in our green box. 114.29 is the force she put in. If we multiply it times the distance, okay, this time it was the short ramp, the 2.1 meter ramp. So 114.29 times 2.1 equals 240. Here we have the same effort as number 1. We can see that the effort changed and became less, but with the ramp increasing length, the work actually became more. Let's take a look now at our discussion question. In our notes this week, we reviewed what work was, and we also got the definition of effort. We can see that when we use the ramps, the work actually increased. How do you explain why an inclined plane gains mechanical advantage, but the work increases? What is the decrease you give you that advantage? So here is from our notes, the definition of work and the definition of effort. Work, using a pushing or pulling force to move an object. An effort is physical exertion. So the work increases because you are having to travel further with the load. However, the effort, the physical exertion, is less because the force you are putting in is less. So we can see that Shannon's work increased, but the effort that she had to exert, her physical exertion, was less.